Hi, and welcome to this second video on simple circuits. And why don't we just go ahead and we'll jump right in. Right, so when we last left off, we were talking about open and closed circuits, and we have our little diagram of our battery and a diagram of a light bulb and our wires. But this is not a very effective way of communicating what we intend to do with our circuit. There are other ways to do this that might be a little better and a little easier. And so what we want to do is create a schematic. And a schematic is a line drawing, is a diagram of an electrical circuit. And we use symbols to represent various components of that electrical circuit. And so what we have here is I have a battery, right? And a battery is listed with its positive and its negative. It's usually a short line and a long line and another short line and a long line, right? And its voltage is listed, right? So this battery is 1.5 volts, right? And the little dot at each end is its node, which is where the wires would connect to. The next device that we look at is a switch, and we've seen the switch in the previous thing, and it's just two dots then with this line. It is almost always drawn in the open position so that we can easily identify it as a switch, right? So this switch is drawn in its open position. If it were closed, it would be connecting those two dots. The third symbol we'll show right here is a light bulb. Right? And a light bulb is just a circle with a little squiggle in the middle of it that is the filament that glows, and then the two wires that connect it. Now, a regular light bulb is not polarity dependent, so there's not necessarily a plus side or a minus side. The wires can connect in any to either side, and the light bulb would still illuminate. As long as the electrons pass through the filament, it will glow. Right? So now what we do is we use lines, right? Straight lines and right angles as much as is possible to go ahead and connect our devices. So here is our battery, and the electrons would flow out of our battery, go to our switch, which when closed allows the electrons to continue, and they flow across, they flow through the light bulb, and then they return back to the negative side of the battery. We would never want in our diagram, we would never want our wires to touch, right? Because that shows us that there is either a short circuit or a wiring problem, and you always want to make sure that your wires are indicated in such a way that they don't cross. Conductors never cross. And let's go to our next one, right? We can change out to various other types of a load. Here I've drawn a buzzer. Right? So this is just a little electrical device that'll make a noise, not dissimilar to maybe your doorbell in your apartment or a buzzer on your stove that goes off to tell you when the oven has been preheated, or a timer on your microwave that goes off to let you know when it's time to flip the pancakes. I don't cook, whatever, right? So then another symbol that we could use would be a motor that converts electrical energy into rotational energy. And a motor does have a positive and a negative terminal, right? If you were to reverse the wires to this motor would spin in the opposite direction. And you want the fan to blow on you so that you stay cool rather than blow away from you. So different kinds of loads. The other thing that we can do is we can change out power sources. Right? So in this example here, I've changed out the power source from a 1.5 volt battery in the last example to a 6 volt battery in this example. And that means now that I'm applying 6 volts all the way through this system. That increase in voltage means that the electrons are more excited, right? So more excited. There may not necessarily be more of them, but they are much more hyped up to go do whatever it is that they want to do. We can also then change this to 120 volt AC. Now we spoke about AC voltage versus DC voltage, and a battery is DC. In 120 volt AC, which is household current, the current travels in a sine wave. The voltage is traveling in a sine wave, and it's alternating from a plus state to a minus state. And so we would indicate it this way. even though it's traveling in an alternating current, we do think of it as having a positive side and a negative side, even though it's doing a push-pull. Right? So I think that this is a good place to stop for now.